It is always one of my favorite days. And to be honest with you, it has something to do with how many views I usually get when I have Scott Walter on. Hey, Scott, no, it's really about you. It's really about how much I enjoy our conversations. Oh, yeah. And then it doesn't hurt that you have now the #1 most viewed video ever on this channel. And I think you might have that distinction on some other channels as well.
Yeah, it's kind of surprising that that happens. And so I'm wearing the Hawaiian shirt in your honor.
I know. And look at me. I'm sitting here in my winter garb, but it has been, California, we've been slammed this week. So it is as close to winter as we get. So
yeah, it wasn't there a song like when it rains in California, I'm trying to remember that, but boy, it rains. Yeah.
Never.
And that's been in my experience too. I remember going out the first time I visited California, I think it's like 1978. It's really dating me. And it had been California been going through this long drought. It's like, oh, come out to California, weather'll be nice. And it started raining. And I remember they said, oh, it's going to have to rain like this for like 6 months before we can announce the drought. It's like 2 days later, like the drought was over. There was just so much rain coming down. And yeah, when it rains, man, it pours. I think that's the lyrics.
Something like that. Something like that. Or
yeah.
That was a salt commercial. I can't remember. But anyway, so there has been a tremendous amount of goings on within the robotic area over the last few weeks. You did a 2-hour conversation with Hans and with James Dalma the other day. I understand you mentioned to me that it was actually a few weeks ago, but it just came out. Fascinating. And
so it was only two hours because there was actually at least 3 hours of footage.
Yeah, he must have gotten it down to 2 somehow.
Poor Hans, man, he had to distill quite a bit. Yeah.
But hey, we're gonna get into that one in depth in a minute. But first of all, I guess yesterday everybody's talking about the new Boston Dynamics video that came out, and you said you thought we should take a look at that, and you thought there was a fair amount of good stuff to unpack.
Yeah, and I think the first thing I noticed, I don't know if we've got it up and running. Take a look.
We'll get it up and running right now. Let's take a look.
Is that?
So here we have the Boston Dynamics. I hope are you seeing it, Scott?
Yes, I am. Yes.
Okay, good. All right, so let's take a run through. Let's take a run through real quick. It's only a minute. Everybody who hasn't seen it, they can check it out. You can talk over it if you want.
Okay, so I mean, the first thing we're noticing is that Atlas appears to be doing useful work, and and right there, my first comment was it looked like Atlas is giving someone the middle finger, and then I realized, oh, wait a minute, Atlas has hands. So Atlas didn't really have hands up until that point, and that's what allows Atlas to be able to do some useful work, and so, the first thing was, and if you look right there, I mean, you'll see there should be like a placard on there that's describing what the bin is or something like that. And it's really blurred out, so we can't read it. So the thing is, there's like some important information about maybe the customer or something like that. So I had 2 questions. Where is this? And who is the customer? And Brian White was able to identify really quickly. It's actually the Boston Dynamics laboratory, because it looks just like the setups that had everything else. So it's very clear. And you notice the floor, which is normally a concrete floor, is padded because I'm sure Atlas falls over all the time. So it's not really, an actual production kind of environment. But they brought in some stuff that probably is on the floor somewhere. And the question is, who is it? And the most logical guess would be probably Hyundai, since Hyundai owns them. And this looks like an automotive part, a strut or something like that, for maybe a pickup, a heavy duty vehicle of some sort. And that Optimus is just moving it from where it would be coming in, probably from whoever makes that. So they probably have a tier supplier that's making that, unless they're making it somewhere else. And then bring it over to kind of a preloader, to where on the other side, you'd probably have operators that are taking that off and then installing it into the vehicle.
Yeah.
And of course, when I looked at it, I had some questions, and connecting the dots had the same questions. It's like, this seems like really inefficient. All you're doing is like picking it up to put it over there, so the next guy can pick it up to put it somewhere else. Why aren't they just picking it straight from it and going on over there? And the answer to the question might be a little bit ergonomics, because it's kind of hard to get it out of there at first and then get it horizontal. And then if you want to make it quicker for people to be able to put it in there. But still, it seems like if it's really fast for them to pull it off that rack, he's not refilling that rack that fast, unless it's like you have a long break between every time they're bringing them in there. So there seems like a lot of things just about the production process, and maybe that's why we don't know who it is, because they're too embarrassed to admit that maybe there's a better way of doing it.
Well,
So
and maybe it's just
yeah,
a demo. It's just
it's
really
just a demo to demonstrate that. So
okay.
the first thing is that Atlas finally has a hand, and you'll notice it's a very non-human hand. It's a very robotic hand without a doubt. It's only got 3 fingers. And the thing about those fingers is they're double jointed, which means that they can turn around the other way. So their knuckles can go both ways. So that means you can reconfigure the hand quite a bit and decide which finger is the opposing thumb, if you want to think of it that way. So it's almost like it's all thumbs and all fingers at the same time.
Right,
And
right.
that's a very nice, I would say, engineering solution to a kind of problem like this. It's your very traditional robotic solution, but it's not really in the spirit of what a humanoid bot should be, where you want the hand to be much more, because telerobotically teaching this thing is going to be really hard if you can't get a decent mapping between the actual hand that you have and what's going on there. So kudos that they kind of came up with a clever solution to a 3-finger gripper that I haven't really seen yet. Also, there are 3-finger grippers out there, but they're a little bit different than so. And they've been able to make it go both ways, and it's able to pick up a part like this. But in some ways, it feels like a very specialized end of arm tooling, which is a problem with robotics in general. Is all the end of arm tooling is very specialized at. Now, oh, right there's a good pause. So you see the corner where there's a big white rectangle in the middle, that square. There's text information on that.
Okay.
And you cannot see it right now because it's blurred out. And
Got
as
it.
you go through there, you'll see it gets blurred out. And at one point, the hand goes in front of it and gets very blurry. So there's something in there indicating, so probably who the customer is or the part or something like that. So they've decided that's not information we want to reveal.
So my first impression, because I didn't see this yesterday, I saw a
Yeah.
couple of stills, but I didn't watch the whole video yesterday. My first impression is there's 2. One is
Mhm.
pretty clunky. It seems so
Yeah,
clunky
yeah,
now
yeah.
compared to what everybody
So
else
I think someone said, "Man, he seems really robotic."
yeah,
I was like, "Oh yeah, exactly." And that everything is like pausing, deciding, going, pausing, decide.
right.
And they said that they talked about basically strength, perception, and mobility
Uh-huh.
are the 3 things. Okay, that's probably a pretty heavy part. It might be more on
Right.
the order of 30 pounds. So it's probably a bit heavier than most of the other humanoid bots are able to carry. So they're trying to show up like, we got a really strong thing here, so we can do really heavy parts.
Right.
Perception does not mean AI. That means you've got a camera system that's able to sort of identify parts in their positions and be able to use that. Standard robots do that already, and they've been doing them for decades in a way. And just that the perception systems have got better and better, more machine learning, more AI has gone in there. But it does not mean they're using AI. It
Right.
probably means they're still using a lot of heuristic, hard coding, everything else
Yes.
for that. And you'll see there's the mobility around there. And there were some interesting things. I'm trying to decide whether they've got a good occupancy net there or where there is kind of failing a little bit, because as you run this ahead, and I think it's, just keep it looping so I can keep on talking over what's going on there. You'll hear it's really noisy when it goes in there. It's like, oh, I've got to do this and that. As it moves around, it gets really close to the corner. It really cuts the corner close. And it's not clear if it kind of clips it and almost loses its balance and then recovers. And it recovers in a very interesting way that if you don't realize that, it almost seems like it's making an emotional response about how awesome I am. I mean, you see, do a fist pump. Did you notice that at some point, you kind of keep it going there after it does the grab, that it does a fist pump to sort of show that, yeah, man, look what I just did. So at this point, we're seeing the overlay of the object it's looking for and also the gripper that's on there. So you've got the synthetic environment in that. I don't think that's LiDAR. I think that is CAD data that they've preloaded for the parts that they brought in. And if you stop it there briefly, you're going to see that the overlay of where the configuration of the gripper should be in the real one doesn't quite line up right. And that could mean a bunch of things. One of them could just be they haven't calibrated the cameras that accurately, but you think you would, because the whole idea is that this is where we want things to be. We want them to line up.
Right.
So I've got kind of some questions about that. And camera calibration is a very challenging thing to get the viewpoints to kind of match with what you want. And there's one company that has mastered it recently, and it's these guys, okay, right here. Because
Yeah,
what's amazing with that, we've talked about proprioception many times, right? The idea
right,
that I can close my eyes and come around here and touch my nose, right?
right.
Do that first thing in the morning. Get up and try to do it, and you'll see you'll miss. And then as soon as you get that, suddenly it's like it sinks in. And then once you do that, you can start like, oh, I even know where my chin is. I know where my ear is. I can hit them like almost the first time. I want to get my forehead here. Oh, see, this fell out, and now if I can go ahead and with my sensors here, oh, now without looking, I can tell this is my earbud. And I know exactly where it needs to go. I didn't even look because my proprioception told me where it is, even if I move everything around there. So that's the world model that you want to have. And that when you start the day, your proprioception in your vision system may be off. What Apple does in the Vision Pro is that part of the calibration is that you have to look at a bunch of dots in space. So they're
Right.
going around there and they are effectively calibrating that cameras to your vision system so it overlays. And when you put that thing on, it's not like you're putting on a pair of glasses where suddenly you decide, oh, I'm going to take the blindfold off and I'm looking straight through this. No, you are not looking straight through this. What you are seeing is you're seeing the world through a screen.
Yeah.
And that means that those cameras they have, it better be projecting that image exactly the way it's going to look like as if you take that thing off. So what that means, if you put your hand in front of your eyes like this, and you look at it, the Vision Pro, you're going to see it there. And if you take it off, it's still going to be right there. It's not going to be like, oops, it's up there. That's a very important kind of thing that you need to sync up. And so when I was looking at what was going on there, it's like, it should be overlaying, and you can see that the gripper is way off. Now I can understand the part would be messed up
Uh-huh.
a little bit because they're not quite sure where they grabbed the part or had something like that. And it wasn't exactly lying in there, but the robot should know exactly where it is. And so if it's supposed to be somewhere, you should see it. And if it's not, it's because it's sagging from where it is because they're putting some sort of inputs. And I would think they have good encoders that would tell them those positions to get it accurately, but maybe they don't. Maybe, that's one of the things with hydraulics is that sometimes you may not be getting the positional information back from what you want. You get a lot of strength and everything else. But if you go back to that video where you see it kind of go around the corner, there were a couple things where again, I wasn't sure whether I should be impressed because it almost looked like its hand was going to hit the post that was sticking up there. And
Oh,
it kind of
wow.
just like went right on over it. And it's like, wow, that's kind of like what us humans would do is like, we're going to cut the corners and we kind of know that our hand's about to hit something. And even if it's out of our field of vision, we kind of know, oh, I better lift our hand so I don't
Right.
bang that post because you probably banged it the first time and like it
Right.
really hurt. And
Right.
so the next time you go around and you're like, whoa, I'm going to like just make sure that I don't get that sensation again. So that's part of like the learning process we go through. And then when it came back with a strut, I thought it was going to run into it. And it seemed like just to get it over that. And it's like, wow, they're really cutting it close. They must know what's going on. But then I realized it's not really the case because it turns out as it's going around, it looks like it clips its knee or its hip
Oh,
on that thing and
oh,
it starts to lose its balance. And then you will see all of a sudden the hand go down like this. And I'm not sure if that's what was like, they're trying to do that reaction to get it from falling over. But if you didn't notice that, what it looked like is he came running around the corner and he was all done. And he just did it like, yeah,
I
just
see.
like the guy who, he just get the base hit and he runs up the first base. And as soon as he gets the first base, he's like that fist pump. So it looked like this emotional outburst from Atlas when you're looking at that. And that's why the guys in the back, they're going like, whoa, what was that all about? And I guess it was like, oh, he didn't fall over this time. So it's, it's pretty interesting to look at exactly what's happening, what's going on, those details. And what's happened is that this is what happens sometimes when you are the first is you develop a platform which may not quite be the right platform and they've locked themselves into it and they're not like, when are you going to iterate? You've got a lot of good information. You did
Or
it with what
maybe,
was the state of the art at the time, and you're still using this platform with all the hydraulics, and you're still taking this engineering mindset of like, well, we're going to design a better hand or we're going to design a hand this way. And it's like, you're going to get more of inspiration from the humanoids. Now, a little bit embargoed here. We had a great interview with the CTO of Sanctuary AI, Herbert and I.
okay,
It's going to be dropped this weekend.
okay,
Definitely want to watch that
all
thing.
right.
Suzanne Gildert, she really explained a lot of things and brought a lot of nuance to the discussion and understanding why we are designing human robots the way we are and why the humanoid robot should have a hand like a human hand, why it should have 5 fingers instead of 6 fingers instead of 3 fingers, and why they should behave a lot like, and a lot of it comes down to, teleoperation capture and being able to do that. Because if you're doing something telerobotically, you want to be able to bring in anyone from the street, fit them up, and they should just be able to do it. There should not be a whole lot of training. I say, well, you see, this robot's got this 3-fingered hand that's really weird that goes both ways. And now you've got to learn some weird kind. It's like, no, it should be natural gestures. So you're trying to capture that. And it's a great interview. You just want to, I don't want to play too many nuggets. It's absolutely worth listening to her.
This is a tease. Yes.
Well, more than that. It's really, it's going to be worthwhile. So,
all right.
And the other thing that, what I'll say about that is that, we've talked about Tesla Bot, we've talked about Figure as being replaced. I've always felt that, Sanctuary is, again, one of those big players out there because they've got good backing. They've been around since 2018. They got a really smart team. They kind of, have their plan. They're pursuing it the particular way that they want to solve the problem, which is good. So, and yeah, you want to keep an eye on them. You definitely want to keep an eye on them. They're up there. And what's nice is that they're taking a slightly different approach than everyone else, which is what we want. Because, if everyone is copying everyone else, you're probably not going to solve the problem because everyone else has to branch out and get different ideas.
Exactly.
So yeah, take a look and then we'll do a breakdown of it afterwards.
Fantastic. So in the Atlas particular one, the other thing that occurred to me was this was almost like the Ford Motor Company taking their ICE car and trying to jam the electrical, the new it's BEV motor into it, and a BEV.
Okay, let's admit it. They're trying to put lipstick on a pig. Okay,
right.
It's like,
but it's
Atlas was a great development platform. A lot of things, and they're trying to say, well, okay, this is a job that requires strength. And again, I agree, we connected the dots. No, this is a job that requires someone to completely redesign that whole process of how you're getting struts to the workers, because it looks already inefficient. It looks like a make work kind of project. It's like, oh, we get a job for a guy to pick up the part to bring it over here, so the next guy can pick up the part to bring it to there. It's like, oh, why can't that guy just bring it to that position in the first place? So there's a lot of things about that. Again, we don't know, who the OEM is. You can guess because it could be the owner. There's no reason why it couldn't be someone else. But to me, it almost seems like a Hail Mary pass. And the more I've looked at it, the more I'm like, it's like, okay, they've done something, but I know a lot of people have been pretty harsh on it. And I was like, I'll give them the benefit of the doubt, because the fact of the matter is, it's not easy to do what they've done. Okay. Let's give them credit there that, just doing anything like that is challenging and hard. And we are comparing it to a lot of the others. And they've got something there, but I think they have to rethink. I think they're locked into the hardware design, and it's time for them to change it, to retire Atlas. That, Tesla has already gone through 3 iterations, maybe 4. You had Bumblebee, Bumble C, you had the Gen 1, the Gen 2. I'm sure the Gen 3 is going to come along. Sanctuary, they've already had their 6th generation, and, and they're going to be iterating for more after that. So you've got to, and it seems like they've really stuck to that platform too long.
Right.
And the other question I have is that, if I recall, it's an 8-hour shift. And Atlas is going to be done in an hour.
An hour.
And then the last thing that a lot of people notice, I don't know if you notice, is like, okay, it was like taking struts out of there and putting them in there. And a lot of people said, that looks a lot like taking artillery shells and loading them into a howitzer. It's like, yeah. So that was one thing a lot of people didn't like about that video.
I see. All right. Well, you just mentioned something that is very big on my mind right now, based on your conversation with Hans and with James Dama, is this whole idea of iterations and where we are in the production, or where we are in the design of the hardware, in particular of the Optimus, because you guys really seem to go at great lengths to talk about where the hardware and the software come together. What is the right timing for building a lot of bots so that the software can get lots and lots of training? When is it the right time to, go into full production? When is what is a final solution for an Optimus bot where it's ready to go into useful productive capacity in the factory? I mean, this is where everybody is right now. It's not like we're thinking, oh, it can't be done. It's like, when will it be done, and what is the right timing? So,
yes. And again, the interview that we did with Suzanne, will fill in some of
Oh,
those data points
wow.
really well to get an idea on her
Teasing that
perspective on
show
that.
again. What's going on with you?
Well,
Man,
it's great, and the main thing is there's a fine balance between getting your software and your hardware solution to match,
all right.
and that if you haven't got quite the right design yet for the hardware, it would be premature to start building them by 1,000. So, agreed that ideally you want to have a lot of these things to be able to do the training set, but there are other ways to kind of build up your training set without a huge fleet at first. And at some point, you want to make sure that the hardware is right. And a lot of that comes down to teleoperation, where you're verifying that you can actually do the tasks that you want. And that's what we've seen. That's an approach that Sanctuary has taken. They do a lot of telerobotic because they're trying to prove out their hardware. And Tesla is doing the same thing. And Milan basically said that, yeah, the whole t-shirt folding thing, that was all about, it's like, can the hardware fold a t-shirt?
Yeah.
And now we know it can fold a
And-
t-shirt. So we're kind of happy with it, but what are some of the issues? So there's a lot you have to sync up there and make sure that when you get ready to start scaling that you actually have a design that is going to work and you're not locked into it, because that's, at some point in the future, 1,000 bots is not going to cost that much money, right? Right now, 1,000 bots is going to cost a lot, because we're not going to be down at that $5,000 or $10,000 per bot level.
Okay, but let's talk about that.
Yeah.
Okay, let's talk about those two things. You've really come down on exactly what I wanted to talk about today. So again, I'm a manufacturer. Yes, I haven't manufactured anything as complex as a bot, but I've got a lot of experience in manufacturing. And my two questions are, let's start with the first one first, and that is, it seems to me that the whole idea of Tesla is that even on a amazingly huge and complex product like an automobile, they got their form factor, they have a basic form factor, and they're willing to iterate on that form factor in major ways, basically on a day-to-day basis, according to everything that we understand. They'll change a part out, they'll go back and get a new part molded and just come in and put it online and make sure that it's operating, in real time. The bot, as complex as it is nowhere near as complex as an automobile. It doesn't have all the issues with wiring harnesses all over the place, all the kinds of things we're talking about. How finished does the bot have to be to where it wouldn't be possible to make huge changes in line, real time, like they do on the cars? I mean, why does it have to be so final before they can set up a line and start producing?
I guess it doesn't have to be so final. You just probably want to make sure your hand is right, that you've got the right kind of actuators, that things not going to break down. And it may be that you suddenly realize that the whole approach you're taking to a certain arm or something like that is wrong, and you want to modify that. But I think they're getting very, very close. Some of the questions like, do we need sensors or do we not need sensors?
Right.
So those could be some of the fundamental questions. And the video that was about, well, because we haven't spoken since then. Did we talk about the latest Optimus video that came out, where Optimus is basically unclothed or unarmored, as Herbert would say? That was about a week ago. Okay. I mean, it seems like 2 years ago now, but I think it was only about a week ago. And when you look at that version of the Gen 2 bot, because the first time we just saw like a standard video that, went through, was edited and stuff like that, and it was highly polished. But this was in the lab of them doing something that was just on someone's iPhone or Android and posted to social media. Right. I think it might've been Elon's phone. I'm not sure, because he's the one who posted it. Right. But in that case, we were seeing all the covers taken off, which meant they were revealing a lot more of what's underneath the skin than before, something that Elon had complained about. Which was copying from that. But the one takeaway is that we saw the previous Gen 1 bot that was being assembled. And remember, the two bots are coming and put together. Yes. And you could see there's all kinds of stuff hanging out and everything. And it didn't look cleaned up. It looked like, wow, it was quite a mess in there. And then you're looking at this wow, that's really refined. Everything is just so clean that now I see why Elon keeps on referring to it. Remember, he used the term 3 times in the meeting. He called it a product, the Optimus product. It's one of the most interesting products. It's wow. Yes. That's an interesting term to refer to it as a product, as opposed to a project or something like that. And
Right.
then when you look at it, you say, yeah, it looks so refined right now. It feels like it's something that's very close to getting ready to scale up. And I agree that, the refinements that you might do when you start scaling it is that, oh, what do we do to change the actuator line so we're pumping out more actuators,
Right.
or doing them cheaper, or maybe getting a little bit more functionality in there, or we've discovered, there's a slight flaw in how the actuators are working. We want to improve them. So you would see that. But I think in the grand scale, it's not going to be a huge change. They're probably very close to being able to do it. And now I did define useful work.
Well, no, okay,
That's been
let's back
termed.
up. Let's
Yes.
back up. Let's
Yep.
go to useful work. Let's go to useful work later. All right. So now that's my feeling is you're very close, or you may already be there to where you could build your line, and you're making arms over here, you're making feet over here, you're making legs over here,
Mhm.
you're making a body over here, you're making heads over here, and you're bringing all these together and in a kind of an unboxed approach, even more likely, more obvious that this would use that kind of an approach of assembling them all together at the end. So it seems to me that just is so clear that the iterations that are possible there, even a complete redo, is not that hard on this product compared to a car, and they do it on the car all the time. So I'm having a hard time understanding why they couldn't get into production with what they have now. Part two to that, though, is let's say that they're just not quite ready. The line isn't ready. They're still working on getting some equipment in, so they're really not ready to go, but they really feel they have a need for 100. Are
Mhm.
these going to be more than 50,000 a piece to build by hand? I don't think so. How could they be more than 50,000? You just told me
Yeah.
multiple times that you've only got $10,000 worth of parts from Amazon,
Well, yeah, well, part of it would be less than that. And I guess just, it depends upon how, like the actuators, you can't buy the actuators. That's the real thing right there.
but they're
And
building,
that
but they're making the actuators themselves.
they're making the actuators themselves. The question is, how much does it cost them to build one? They may not even know the answer, right? So someone has to go in and say, okay, in theory, with the parts and everything else and all the effort that goes into it, are we building them for $500 a piece, 1,000 or 10,000? It's like, I have no idea, because it's, when they're at that level, you could say, yeah, they're kind of expensive. So let's say it costs them $1,000 a piece to do that, which is pretty much the limiting factor. You get 42 actuators on there, and that's going to be about 42,000 right there. And then you get all the other hardware you put in there, and like maybe you can get it up to 50. So
Right.
I don't think at this point it's going to be $250,000 a build if they decide to scale it.
Quarter of a
It,
million each.
well, no,
Oh.
that's what Boston Dynamics. So it's not $250,000 a piece. That's what I'm saying. It's not $250,000 a piece right now if they decided to build them at some sort of semi scale. The first couple of ones may have been. I mean, someone might go out there and say, "Oh yeah, those first couple of Optimus were about $1 million a piece because of the amount of time and everything else." But then there's like other things of like, are they just 3D printing some things, or castings? Now castings can be pretty cheap once you get like a certain volume. If you're talking about like just doing one casting, that's going to cost you a lot
Right, of course.
until you get that. So, the bean counters will be out there and saying that, yeah, the first couple ones are like real expensive because of all the costs of kind of setting up or configuring some things. But
Right.
I agree. Then the marginal cost after that maybe will be a lot less, that you should be able to scale up to 1,000 you want to. You just want to make sure that you're happy with the design, that everything seems to be all right, that you're not missing some critical component. And it may be that they're happy with 85% of the design right now, and there's still 15% that's a big question mark, but others that are very clear are going to be there.
So
But it could be that they're working on the walking right now, and that they find that there's something that they really missed in the walking. It's like they can only walk so fast, but there's a critical design element that got all wrong. They have to redo it, and then they have to go through and maybe change. So there are probably things like that they want to make sure that they can achieve the requirements with the current design they have, and that they didn't lock themselves in that suddenly, oops, it's like the leg is completely wrong. We're going to go back to the drawing board. So we'll see.
Okay, so but if we take a really high number, and like you're saying, not the first one, but the 15th one is $50,000, and we multiply that times 100, you're only looking at $5 million. You're looking at a drop in the bucket. So when
it's a rounding error when it comes to what Tesla is able to spend, and they're very capital efficient.
Yes, yes.
So we're,
And
we're
so,
yeah,
so when James is worried about them falling over and hurting themselves, you know, and I'm thinking to myself, it's $50,000 if it hurts itself, but it might only cost $500 to fix the owie.
right, right. And part of it is that they make sure there's like a lot of padding, like you see what Boston Dynamics made, is it kind of child-proof the environment. So
Right.
if something does go wrong, it's not going to get broken, because they were having a lot of problems. All those videos they did, they had a couple of Atlas, and it was constantly falling down and breaking. And then the thing
Right.
that always
Right.
surprised me is every one of these bots is when it falls down, it just doesn't do anything to protect itself. It's like, come
Yeah.
on, just get into that curl. It's
Right.
like anyone who's a gymnast or something like that, it's the first thing you're taught. You go to the rock climbing gym, they won't even let you start climbing until you can show them that you know how to fall without hurting yourself.
That's
So
right.
that's like the first thing I would do is I would build this muscle reflex into
Yeah.
the bot, that when something like that happens, it just like
Mm.
just goes into this mode that we know it's going to be able to fall without damaging itself. So
Okay. All right,
it's,
Scott.
I think there are things you can do that you can be untethered and get the training data without constantly breaking it, because you're not trying to do backflips. All
Yeah.
right. If you're trying to do backflips is something else. If you're just like picking apart over here and you trip and you fall down, it should be able to fall down gracefully, because guaranteed it's going to fall down in
Yes.
production anyway, because it's just going to happen every now and then. So you want to be able, and that I think would be really critical data, is when it falls down, what parts is it hitting? Is it like always landing on its elbow
Oh
and like,
yeah, yeah.
breaking its elbow? Well, if
Right.
it is, maybe we design some special elbow pads. It's
Yeah.
like, think about people who were skateboarding. What's the first thing they
Right.
learned
That's right.
about skateboarding? It's like, there's certain parts of the body we need to put
Yep.
pads on, okay, just to make sure we don't break ourselves and end up in the ER. It's going to be the same thing with the bots. You begin to figure out what parts of the bot do we need to protect a little bit more, and is it done with a little bit of padding, changing up the environment? What's it going to be?
So this morning, on a kind of a related but semi-related subject, Ford came out, or maybe it was yesterday. Ford came out and said, "We have a skunk works where we have been developing our quote, they didn't call it this, but their Gen 3 vehicle, their vehicle that's going to compete with Tesla's Gen 3 vehicle, or their platform, if it's going to be a platform, whatever it's going to be. But they've got these skunk works, and they announced it. Nobody knew. Nobody had a clue. Apparently, everybody was in the dark about the skunk works. And you're telling me, people keep trying to tell me that Tesla can't have a secret skunk work someplace that might be doing stuff on robots that they're not talking about. So here's our public facing demonstrations of what we're doing with regard to the bots. But over here, we've got stuff. No, we're not going to tell you this other stuff. Do you think, I mean, it seems to me that's entirely possible, plausible, feasible, and maybe even likely.
Well, Elon telegraphed that a little bit about saying that, oh, everyone's looking at our videos frame by frame. We have to be careful what we release. And I mean, we know nothing about the Gen 3, or what is it, the Gen 3 platform, or the Model 2, whatever you want to call that thing, the next one that's coming out.
Yeah.
All we've seen is like on the PowerPoint, it's kind of covered up and everyone's speculating what it's going to look like.
Right.
We know nothing more except, Franz saying it's like, one of the best vehicles, and he just can't talk about it. So they clearly are able to do that. And what if you want to call it a skunk works or something like that? And, as far as Ford, I mean, something smells about that
that's another
that
subject.
announcement, because if anyone says, "Oh, we were surprised," it's like, no. Farley already talked about it like over a year ago on one podcast when they were talking about the F-150, and he found out that, wow, wait a minute, we were trying to do the design in the traditional areas, and people kept sabotaging the whole thing because they did not want to see it succeed. So they set up a skunk works basically in downtown Detroit, a completely different group, to design the F-150 the way it should be done.
Right.
Now, maybe they didn't call it a skunk works, but as far as I'm concerned, that's what that was.
Yeah.
And I'm not surprised they have something else. So, I mean, every company always does that. They will have a different group that's got to be future looking, to really think about it, where you want to make sure you don't poison the well with some of the ideas. You almost intentionally hire people from outside the organization and put them over there, and maybe get a couple of skilled people that are forward thinking, that are not going to be, kind of trapped in the past, but know enough about how things are done, organized, that they can maybe make sure that they direct it the right way, or realize, oh, wait a minute. It's like, you might want to know about this and that, and why it's going to be difficult to do that. And then, then hopefully he gets pushback from others to say, yeah, but that's still the old way of doing it. So you need a little bit of that balance that's in there. And so I'm not surprised.
All right. So now let's talk about it, the bot the overall bot industry, the humanoid
Mhm.
bot industry, and the potential that there may be different approaches and
Yes.
and what maybe Tesla is doing versus what other people might be doing in terms of just ways of thinking about things as well as cash flow, etc. I mean, Tesla has all the advantages because they have the manufacturing capacity. They have obviously they have the software, amazing, huge, capacity, the AI capacity, and then they have the cash. So they have more advantages than anybody else in terms of being able to put this thing together in a way that's going to be absolutely amazing. So it allows them the benefit of being able to think about how do we do this for the long term in the smartest, the wisest way. On the other side of the coin, Elon usually seems like he likes to get the cash flow going. He doesn't want to
Yeah.
sit there forever and not get something out there which creates some kind of cash coming in. So taking all that into consideration, usefulness. So you were almost
Right.
tangenting into usefulness a minute ago. James Dalma said, you and I have said for months, so this is not new, that the Tesla bot, as it exists today, can go into the factory and do useful work. We saw it wasn't even the first generation. I think it was
Mhm. It could
the
do a particular task. Yes.
it can pick something
Mhm.
up, take it over. It could do pick and pack, or it can do pick up and put down. It could pick objects out of a line. If it was a line coming by in the Lucy Arnaz,
Mhm. Mhm. Yep.
situation, pick something up and then put it over here, pick something up and put it over here. All those kinds of things it can do now, has been able to do for a long time. So there are useful tasks that it can do. Elon seemed to be saying that he's looking for something that is more of a generalized solution before they go public with it. Is that what we're waiting for? And Dalma kept repeating it over and over again. I don't know how many times he said it, maybe 5 times in that 2 hours. He said more of a generalized solution so that when you unpack it, you can take it over. It's never seen the job before, and you can either tell it or show it how to do the job, and it can do the job. Do you think that Tesla wants it to get that far along before they put it out for rent?
Oh yeah, for sure, for sure. So the question is whether they're taking a general approach where it would be able to work anywhere, or more of a narrow approach where it works in kind of specific environments. So now they're probably a bit more narrow to meet their own specific needs. So within the factory, you've got limitations of what you want to have. In many cases, you can even look at the design of the hands. The hands are designed in a specific way that they will be able to do most of the applications you need to have done in the factory. They may not be able to do everything you want outside the factory because it doesn't maybe have enough knuckles. It doesn't have, the ability to spread the fingers out. I think James Dama has even explained that, there's some amazing things we can do with our fingers. We can do this with our fingers, whereas the bots right now can only do that.
Hmm.
Is that important? It's probably
Yeah.
going to be important in the general case, but in the narrow case, it should be fine. So, but a lot of times don't get caught in getting the 100% solution. Pareto's law is that 80% of your requirements can be met with 20% of the effort, and the last 20% is where like 80% of it goes in there. So you want to define where you start getting something that becomes useful. Now, Elon has used the term useful work. Brett Adcock also used that term, and I was like, okay, I think I know what they're meaning, but no one's quite sure. So they think, we saw it was able to go in and pick up something, move over there. It's useful work. It's ready to go. It's like, no, no, no. You've got to look at it in the big picture. The thing is, you've got a task that's being done on the shop floor right now, and you are paying someone to do that task for 8 hours a day. So there's a certain cost that goes along with it, right? If you decide to replace that worker with something else, that thing better do the task with the same efficiency, quality, duration, and cost parity. Otherwise, it's not useful. So you could bring in any piece of automation. And if it turns out that the operating cost for that thing is twice as what it was when you had the human worker there, you're going to realize, what a mistake. I should not have bought that piece of automation. So you do those studies ahead of time to see how much it's going to cost you. So yes, Optimus can probably go in and demonstrate a bunch of different tasks. I'm sure the figure robot has already been able to demonstrate a few tasks. Atlas just demonstrated what looks like useful work, but the first thing I said is like, but let's see if he can do it for 8 hours.
Right, right.
And is it doing it at the right cycle time? So one of them is like, it's able to do it, but is the human worker doing it like a little bit faster? Now, it doesn't matter whether the human worker is a little bit faster. What matters is whether the human worker is doing it in the tack time. And usually the human worker has leftover time because you never want the human worker to be at 100% utilization.
Right.
It's going to be like 80% because they need to take a breather. So if Atlas is able to do that task in the tack time, okay, it's all right. It's all right. It can be a little bit slower than the human, but if it's doing it, and is it doing it reliably?
Right.
You know, how often is it like completely messing up and missing its tack time, or just having a failure of gripping or something like that? So you've got to have the reliability that's there, and the same kind of quality, that whatever is the operation you're doing it, that you're not having failures in the operation, that now there's you've screwed up the part,
right,
because you're not placing it down right, everything. So you've got to do that. And it's got to be able to do it through the whole day, and then show up again the next day and the day after that. And so it can't be one of those things that's like, wow, we proved it for 8 hours and like the thing is completely worn out and we need 5 hours of preventive maintenance to get it ready the next day, you know?
Yes,
So
yes.
it's and so in the end, what I'd say, it's a very simple thing, is that it's useful when it can do that task at cost parity. Right. And if it can't do it at cost parity, it's not useful.
Okay, so let's take a quick tangent on that then, because you have the two issues. You have the probably the rent, okay, as opposed, you could have the amortization if you're buying it, but let's call it let's call it the rent for now. And then you've got the ongoing maintenance and supervision. So another thing that James said, and I have the utmost respect for James, but James said it's clear that the current Optimus bot would not be useful in that term. In other words, it would cost too much to make it for it to be useful to replace these human workers. You and I have done these numbers. I just put out an analysis the other day that I saw that others have now either seen mine or they've come up with their own, where it's probably at least double. The advantage of the bot is probably at least double what the actual cost per hour of the employee is. The normal, what we see as his wages plus the 35% overhead, you know, let's call it $25 an hour, $30 an hour for that. It's probably double that by the time you talk about hiring, training, retraining. You know,
but it depends on a lot of factors. I mean, first of all, if it can't do it in the speed and the time of the worker, then you just can't. It doesn't matter how cheap it is if it's taking twice as long.
It can't do it. What you're saying though, if it can't do it, like for instance, I've talked about bottle capping. Okay, so we'll use bottle capping as an example. If it operates at the same speed as the other person, it doesn't matter because there isn't a next operation that is feeding.
Right.
Okay, it doesn't really matter in that situation. Some situations it matters because it has to be able to put it in at the same speed where the next operator is operating. But in many cases that doesn't matter. It's just a matter of do you need two bots to do the job instead of one? Then because you got
could be, if you can parallelize it, you know, in many cases within a certain cycle, the human operator may be responsible for really doing like 2 operations in there.
But let me just go back
and if you could say, well, 1 bot for each one, the bots are really slow, but we put them there. So then you go look at, well, how much does it cost the bot per hour? That's a difficult calculation because you might be saying, well, let's just look at how much electricity costs, right? I mean, that's it. That's how much it costs. It's like, well, it's a bit more than that. It's the cost of the bot. And the chance that you have some white collar workers standing behind the bot, sitting there managing the whole thing, and how much does that cost? So it's not an easy calculation, and they're going to figure it out. And I agree in some sense, it doesn't matter how much they cost right now. It's like, can they just do it? So like all those things I talked about, you know, efficiency, quality, you know, making sure they do it in the right time, and the duration, you know, can they do the whole duration? I don't care if it's $100 an hour right now. I want to put them down there and I want to demonstrate that they can do all those things, because I'm confident that $100 an hour is going to get down to 10.
Right.
So you can do that. And then someone will argue, but yeah, it's not useful work. It's killing the margins. It's like, I'll agree with you that it's killing the margins. But if we continue on that path, we can see that we can drive the cost down. The reason it's really expensive is because, you know, for 1 bot, we've got 5 minders that are sitting there, and guys on laptops are doing all these things that are verifying all that stuff. to make sure it really, really is working. And at some point, they're going to back off and say, well, we don't need that many people. We found a way to be able to bring the cost down.
Right.
So once they get there, they will be fine. And I have a feeling there's somewhere in that middle ground right now that they're getting a lot of that done.
But we have lots of bots that are out there now. This is not a new issue.
Yeah.
It's not a new
Right.
problem. This is not hard to compute. Everybody's been doing this. I used to do it all the time. I didn't have any, I didn't even have any of the bots. I had just automation equipment where you're making coming to these same conclusions. So
it comes down to cost per unit. What's the cost per unit of the automation versus labor?
And if this bot costs $100,000 to build, and you want a $50,000 profit, and you sell it to me for $150,000, and it takes another $50,000 a year to maintain it and keep it going, that's $200,000 my first year. I think I can prove that I get $200,000 worth of work out of it the first year. So I'm very confused as to
right when it's ready to come out of the box. Basically, like James said, it has to be in a situation that it just comes out of the box and works. Right. There's a good chance that when they're going on down there, it's just not out of the box. It's like the whole team is down there and they're checking all this stuff and they're doing everything else because they need to kind of get that data. So it's like maybe very expensive to operate each bot right now because of all this overhead that's in there that eventually is going to disappear once they have got it down. But for right now, you might be able to argue the hourly cost is just too much. And I'm sure they're looking at a path of like, all right, how can we do a little bit more? Getting it runs some of these things, verify that it can do an 8-hour shift and then another 8-hour shift, and another one after that, and then start backing everything off and automating a lot of the performance data that we're getting and having some people on call that, if they have to go over and fix something. But right now, I just have a feeling there's a lot of engineers sitting around watching that thing do that, and they're all getting paid.
But but that's all R&D. That doesn't fall into the actual cost of what.
That's So the question is, how do you calculate the OpEx for it right now?
Exactly.
And you throw it more in like the R&D, but that is unscalable. Okay, if you need, let's say, have 5 engineers right now for each bot.
Right.
You're not going to scale that up to 100 bots tomorrow. You got to get that down, and then at that point, you can say, all right, now we can start to scale.
Right. Okay. So, having said all that, then the next question, we've talked about the usefulness. It is possible that Tesla could decide this this Optimus bot now can do 50 or 100 useful tasks in factory settings for which there are tens of thousands or hundreds of thousands of jobs, whether that's folding a t-shirt, putting a cap on a bottle, moving a piece of metal from here to there so that the next bot can pick it up and take it on to the next. All those kinds of things we've been talking about for months. Not ready to pick up grandma and move her from her bed to her chair, but it's ready to do a lot of factory work in the facility in a more or less confined environment where you're not expecting snow. You don't think there's going to be any dogs nipping at the heels of the bot. So there's, it's a confined environment. So
except for Marvin, probably.
Marvin. Yeah, there's always Marvin. That's
Elon's dog, for people who don't know it. And the dog usually follows him around everywhere he goes.
So you have those kinds of, so you could get to a place, which I think maybe James was also saying, which could be later this year, could be next year, could be later this year, where you're turning some of these loose. You've got 10 or 20 or 30 or 50 or 100 that are now in the factories, in Tesla factories, but they're literally now performing their task on a regular basis. And then you could, if you had 50 or 100 tasks that they can do, and we've proven in our own factory, you could start putting these things out for rent in somebody else's factory. So now you're starting to develop your sales and service team, your engineers that go with the bot when they do the setup, et cetera, et cetera. You can start actually finding out what it's going to look like in the real world when you're working with the customer.
Yeah. And so I kind of concur with Elon's statement that the expectation, when he said this last year, is like, sometime next year, the bots will start to be doing useful work. So sometime in 2024, we expect it. And, I think by the middle of the year, they may be doing it, whether they, maybe already. The question is when they kind of announce that and show, the proof of work, I guess you can say, that it really is going out there and doing it to demonstrate that. Expect that sometime this year. then he made the statement about, shipping sometime next year, meaning 2025. That caught me a little bit off guard, thinking that, wait a minute, are they really thinking of shipping outside of Tesla, or are they talking about internal shipments? They'll be shipping down to Giga Mexico in 2025 or somewhere else. So I'm still trying to interpret whether he really means external customers or more of like their own internal customer. Just I'm still trying to process his comments about Optimus being a product. Because
Yeah.
when you talk about something being a product, you're talking about something that you are selling outside the organization, not necessarily something within the organization. So that's something we need to circle back to later on in the year to see exactly how that's kind of progressing. I'm not 100% convinced that it's going to be going into external customers' hands in 2025, but I could be completely wrong because they may be making way more progress than we see. They're not going to tell us everything that they're doing, and they have a better handle on that.
Well, look what they're doing with the semi truck. Okay. And again, I did this in my own companies. It's like I got a product to a place where I wanted to put it into a retail environment, or where I wanted to put it into a working environment, where it was real. Because commonly there's things that you just don't know until it gets into the real world. You can do it in your factory all day long, and you think you've thought of everything, but until you give it to a customer. So Tesla gives the semi truck to Pepsi. They put whatever it is, 27 or 50 or 35, I forget how many, out there with Pepsi. Now they're driving those babies all day long, and they got truck drivers that are doing it, and they're going into truck stops, and they're stopping in motels, and they're unloading and loading in different environments and different temperatures, and they're finding all kinds of stuff out, which has allowed them to do a whole bunch of probably improvements before they actually
before they scale. Yep.
Yeah. So I think that's what I would be doing if I was Elon when he says he's going to ship. Hey, it might be very limited next year. It might be 2,000 or 3,000 bots going into Pepsi. It might be going into Pepsi. I suggested In-N-Out. That would be the perfect place to test the burgers. The burger flipper, okay, is an In-N-Out.
Yeah. There's plenty of places. I agree that that Tesla is becoming very methodical with the semi. So they're getting it out there. They're getting really good data on that. At the same time, they're getting ready to scale up. But for everyone else, it's been kind of frustrating. It's like, oh, why can't I get the semi in my hand already? It's because they're going through and we saw the same thing with the Cybertruck. All those release candidates, like, oh, come on, when is it going to be? When is it going to be? And that's because you've got to go through. You've got to do the methodical testing. You want to make sure everything's all right. And even then, after you do it, you're going to find there's a few things, and you need to circle back and make some of those changes. And everyone recognizes that. You could see, Figure. They said, well, there's so much we can do in the lab. That's why they wanted to go to a real customer. Sanctuary has already been doing that for a while. They did some jobs at inside Canadian Tire, like well over a year ago, to collect really useful data, because you don't know until you go out in the real world what those issues are going to be. And then you've got kind of this, how many bots are going to be produced, how many you need, how much of that's going to scale up. We've been working on a couple of models. Cern Basher has put quite a few out there looking at that, where he has what looks to be a reasonable kind of ramp up, where the numbers don't get crazy until into the 2030s, and it's one of those things that they're going to creep up on you. So the numbers will be okay at first, and then they'll start getting bigger and bigger and bigger, and where in the early years it'll be really easy to 10x each year.
Yeah.
So if someone produces 10 bots this year and they're really happy with everything, it's pretty clear they can do 100 next year. That's not going to be hard. And once you get it to 100, getting up to 1,000 really won't be that bad. And then even 10,000 after that. And then, it starts to maybe get a little bit more challenging as you start 10xing up there, but it doesn't matter. I mean, you can see a pathway to 1 million over a course of 6 years where you're 10xing. And then after that, you might say, oh, it starts getting a little bit harder maybe, but we could be wrong. Maybe it doesn't get harder. If the bots are really doing well, it's like you end up getting it, accelerating that rate. So but Scott, if you're very conservative, you can get to those numbers in a realistic time frame.
Yeah.
And again, just look at Herbert's video on the weekend, and we'll get kind of an idea of someone else's idea of what that scale is going to look like.
All right. And so I saw Cern Basher's analysis, and I was looking at it, and I thought, and I'm just going to ask you this question because you and I are tending to be more optimistic than some others, but I'm going to ask you the question. I want to be as realistic as possible here. Why would it be any harder to ramp the bot than it would be to ramp the Model Y?
Oh, it'll be a lot easier.
Okay,
It should be a lot. And again,
we
the
didn't
analogy
think,
is like, it's not as complex as a Model Y, but
we didn't
more
think it was going
complex
to
than a
take
cell
six,
phone. So it's
we
somewhere in
didn't,
between.
we didn't think it was going to take 6 years to get to 1 million Model Ys, and it didn't take 6 years to get to 1 million.
No,
Model. Oh, no, it
no.
took a couple,
So
three.
they could, and the thing is that if they really want to, they could do it. And part of it could come down to, does the bot have the capability that there's actually, 1 million customers out there that would really want it,
I don't have
that you
any.
want to put it in, and that's what I don't know. It's if you have something just like, the cell phone was clearly at a state that there's more than 1 million people that wanted it, and it was useful enough despite any glitches it may have had in it. Those customers want it and they still want it. And with a lot of technology like that, and of course there are a lot of people that want the bot, but if the bot is going to have like all kinds of problems right out of the box, then you don't want to be giving it to 1 million people.
No,
You'd be looking for the early adopters, and then once you get to the state that you feel like this is really working, then you would ramp up. And I agree, it's like you could, it's like, but we're trying to be conservative on the numbers. So everything here to look at what the potential is, a long-term potential is, the numbers are conservative enough that I think very few people, I mean, the only skepticism you would have is like, the bots are never going to happen. It's like absolutely impossible. There's no way you're going to get the AI for it. It's just not going to be a thing. But if you sort of accept the fact that, yeah, these could become a thing, and it's just a question of what that S curve looks like, and you start modeling it out, you begin to realize how S curves creep up on you, and suddenly things just change overnight.
Right.
So that's, and there could be certain kinds of resistance to the bots and everything else, and how disruptive they're going to be, and whether we want to slow walk it and all that thing. So you got to look at it also through the regulatory framework.
Well, if there's resistance in the regulatory frame in the United States or in individual states, they'll just sell more of them in,
somewhere else,
in Germany or in Japan or someplace where they are, South Korea, which is very forward facing. So, all right.
And have demographic issues that, are like, we need to do this. Now, let's circle back to you're saying, yeah, but the bot's not ready for the nursing home, right? In Japan, they're going to be, the demographics are such that they're having a problem of how they're going to take care of the elderly because of the kind of the inversion of the demographic curves there.
Yep.
And so you're imagining it's like, well, we're going to need the bots to go in there, but the bots can't do it. However, the bots can do a lot of other things. And if the bots are able to do that, then you're able to free up part of your workforce that now they become more available for these other tasks that they're not there for. So it doesn't mean that the bot's useless in solving that particular crisis or problem. It can be very useful, even if it's not direct.
Right.
So that's, I think, part of what everyone's missing is that we've got a labor shortage. I mean, it's clear there's millions of positions that are available that no one wants to take, or they don't have the skills or something like that. If we can start to plug that with the bots, now that means it's a lot easier for these other areas for the labor force to be able to move into those. So that's one lens that you need to look at it through.
Oh, and the other big one that nobody ever thinks about is, proven by iPhone in so many different ways, is that there are things that the bot will end up doing that you cannot do now. Okay. You can't do it because it's inefficient. You can't make it cheap enough that somebody will want to buy it, meaning the product. You can't, using human labor, I don't care if the labor is in the cheapest country in the world, it's still not cheap enough. But when the bot can do it for $3 an hour, and do it consistently,
Well, think about like recycling.
Yeah.
I mean, that recycling is really hard. This just comes in, and it's a mess of things that you're trying to do. And very few people want to do it.
Right.
And, even if they do want to do it, you're paying them a wage that is just so high. It's like,
because it's nasty.
It's not worth to recycle.
Right.
But if you get the bots that'll just be in there separating all the stuff and are able to quickly tell, oh, that's pet 3, that's, that's number 2, that's I can't tell because they don't mark the things right. But you can just imagine now, wow, and then people will recycle more, and people will want to do it because, it's actually efficient. Right now, a lot of those things are inefficient because of the incredible labor cost that goes in there.
Yep.
And no other way of being able to automate some of these things because even the hard automation has been trying to solve that problem, and no one's come up with a really good solution yet.
All right, I think we've done it. I think we did what we wanted to do today, Scott. I wanted to make sure that we were taking a look really at where we are today in terms of the reality of having a bot that is going to do useful work. James, you, I mean, we can go down the list of the people that all agree the bot is doing useful work, can do useful work now. There's just no doubt about that.
Yes, yes.
The question, could they take this exact bot and put it on a production line right now and produce it at a price that probably is going to be, not probably, is definitely going to be, something that is successful as a product? I think there's absolutely no question about that. Yes, will there be R&D costs or CapEx costs that are involved in the early days? But those are really on Tesla. Those are not on the customer.
Yeah. Well, the other thing is like, just going back to this thing here.
Yeah.
The reason why this is so expensive is not because of the cost of manufacturing,
Right.
but because, according to Robert Scoble, there was like close to $40 billion of R&D that went into this.
40 billion.
Apple has to recover the R&D expenses. So that's why it's going to be kind of expensive at first. And then eventually it'll come down as they find cheaper ways of being able to do it. But there's a lot. So you're right. When you look at Optimus, how much did it cost? And then you need to put that R&D cost into your factor of it. And the more you have, of course, it goes down. But the bean counters are going to be sitting there, and we'll be able to say, "Oh no, it's costing you this much right now."
Getting the money back on Optimus is going to be a completely different situation than getting the money back on those headsets, because what you basically have is you're renting it out. And I've said 60,000 a year profit. Could, in the early days, I've said it over and over again. You could probably get $100,000 or $150,000 a year profit if you want to charge that much, because the use cases in the early days could all go to people that have 4 shifts, could all go to people that have higher, the higher value tasks involved. So you could probably get $100,000 a year per bot. Well, you multiply that times 100,000 and you've got, I don't know, but it's a big number.
It's a really big number. Yeah, exactly. Yeah.
So anyway, Scott, we need to wrap it up. I've invited Scott to come on once a week. We think we're going to do that because we think there's enough now information coming out each week that we need a weekly update. So where we got Brian on Mondays and Tuesdays, maybe it'll be Scott on Wednesdays. And that will help us to all stay really on top of the most important product that maybe has ever been designed and developed. Not maybe, I think there's no question this will be the #1 dollar generator and the #1 most productive wealth creator for the entire world that's ever been done. Scott, as always, so appreciate you coming on the channel.
Yeah, same. Thanks for having me back. And I'll have to come up with, I guess, another collection of Hawaiian shirts for Wednesdays.
Yes, well, I guess maybe on Wednesdays I'll have to wear my Hawaiian shirt even in winter, just to make sure that we're on together on this. All right, thanks, Scott, and to all of you. All of you out there, it's been great talking to you.
Same here.